We're now ready for problem 19 of this review. So this starts with what we call function notation. So 19, we're given this function 5x squared minus x, and we're asked to determine all of these. So let me just go ahead and write it down, and as you go along, you can see what they're asking for. So the function f of x equals 5x squared minus x. And they ask us to first determine or calculate f of -2. What that means is f of negative, you go to your f function, every place you have an x, you replace it with a -2. So 5 times x squared becomes 5 times -2 squared minus x. X becomes -2. So this is -2 squared is 420. 20 plus 2 should be 22. Then they say negative f of 2. So this means I'm going to go figure out what f of 2 is and then tack on the negative sign. So sometimes what I do is put the negative here, then f of 2 is going to go in here. So f of 2, once again, in my f function, replace x with 2. So 5x squared becomes 5 times 2 squared minus x minus 2. So inside these brackets, it's 4 times 5, 20 minus 2 is 18, but then it ends up being a -18. Now you can also, instead of plugging in numbers for x, you can plug in other variables or letters, or maybe you call them constants. F of a says you go to your f function, every place you have an x, you replace it with a. So 5x squared becomes 5a squared minus x, but we put in an a for x. So f of a equals 5a squared minus a. F of -a, hopefully you get the hang of it. It's not that hard. So now I'm going to replace x with -a. So -a squared minus x minus a -a. So to simplify this, -a squared is just a squared. So this is 5a squared minus a -a is plus a. It looks like there's one more. Negative f of -a. Now, here's a case where I don't have to start from scratch. I've already figured out f of -a is this. So what I can do is just put the negative, and f of -a is 5a squared plus a, and then I distribute the negative sign. All right. They give us the second one. Here's this function. Now this is sort of a special kind of problem because this right here is called the difference quotient. And if you go on and take a calculus class, you will see this again. This is used, very important equation for calculus. So they go ahead and they give us a function notation problem, but end up having us figure out the difference quotient. So our original function for 20 is f of x equals x squared minus x plus 3. First thing they want you to, it's funny how, let me just show you what they're doing here. They're sort of holding our hand and leading us along. Because if you look at this final difference quotient, it's f of a plus h minus f of a over h. So they sort of break it down. The first thing they have us find is f of a, which is right here. Then they have us find f of a plus h, which is up here. So I think the idea is we're going to find f of a and f of a plus h, and then we plug them in here to do the whole difference quotient. In other words, they ultimately want to know what this is, but they sort of break it down into pieces to make it easier to manage. So the first thing they want to do is f of a. So every place I have an x, I put an a. And then they want us to do f of a plus h. Every place I have an x, I replace it with a plus h. So x squared becomes a plus h squared minus x minus a plus h plus 3. Now this, we need to go ahead and multiply this out and simplify things. A plus h times a plus h. It's like you have to FOIL those. And if you do that, you end up with a squared plus 2ah plus h squared minus a minus h plus 3. So now the last part is what's called the difference quotient. So it's f of a plus h minus f of a all over h. So here is f of a plus h, this big monstrosity. So I'm going to put this whole thing in for f of a plus h, a squared plus 2ah plus h squared minus a minus h. So that's f of a plus h. Maybe I'll even, then minus f of a, which is up here, a squared minus a plus 3, and all of that is over h. So what we have to do is we have to sort of combine like terms, and if you've done this correctly, you're going to see a lot of these things cancel out. So first realize that minus this parenthesis, everything in here, the minus gets applied to. So for instance, I have an a squared here, a squared minus a squared. They cancel out. In fact, I'll just do this. How about I have a negative a here, negative a minus a negative a. Well, you subtract the negative a, that's like plus a. So minus a plus a. So these cancel out. And then look at here, 3 minus 3. The 3's cancel out. So by the time you're all done, you're left with 2ah plus h squared minus h all over h. Now, since you have 3 terms up here, but they all have an h in it, I can cancel an h, this h, and all the h's up here. So end up with 2a plus h minus 1. All right, so that's the difference quotient. So what's next? All right, now we look at functions and we're determining whether they're even, odd, or neither. 2 problems. Pretty straightforward way to check. So let's just do it, and then I'll remind you of what we check for. So number 21, f of x equals 2x minus x squared. The way you check even, odd, or neither is you take your function and you find f of negative x. So I take my function, every place I have an x, I put in a negative x. So 2 times negative x is negative 2x. Negative x squared is x squared. So f of negative x is this. Now you ask a couple questions. Here's the check to see if it's even. The even check is, does f of negative x equal your original function? So here's f of negative x. Is it the same as our original function? It's close, but you notice here I got a negative. So therefore, this is not an even function. To check for an odd function, you take f of negative x. I should put a question mark there. Does it equal f of x, but with a negative up front? Now, the way I like to check this is I'm going to go ahead for my f of negative x. I'm going to go up here and I'm going to factor out a negative 1, and you'll see why. So negative 1, so this becomes 2x plus x squared, which I could also write like this. Now, the reason I do that is because for the odd test, so this f of negative x, I've rewritten like this. Does that equal a negative, my original function? So here's a negative. So the question is this the original function? And you check it, and it's pretty close, but the difference is this is subtract, and this is add. So they're not the same. So it's not odd. So if it's not even, it's not odd, then we say it's neither. So 21 is actually neither. Let's look at 22. 22, same question. Here's the function. Three x times x squared minus 4. So let's see what f of negative x is going to be equal to. So 3x becomes 3 times negative x, and then negative x squared minus 4. So it looks like this is going to be negative 3x x squared minus 4. So the even, does this f of negative x equal the original function? Well, once again, it's close, but this was negative, so no. Odd, can I take the original function and put a negative in front of it? So here's the original function. Can I put a negative in front of it? And would that equal this? And you look at it, and it actually does. So you know what? We say that's actually an odd function. All right. So what's next? All right, transformations. Find the equation 23 for a function that is finally graphed after the following transformations are applied to the graph of. So here's what we call the parent function. We're going to shift it left 7 units, reflect about the x-axis, and shift up 11 units. So in class and on the exam, you'll be able to use this little chart here, right? So here's the original graph. And this says, here's the effect of things you do outside the function. It's like you just tack them on to the end. You add 2, it shifts up. You subtract 2, it shifts down. You multiply by 2, multiply by like a fraction 1/2. And then here, the second sort of column is what happens inside the function. You actually add something to just the x. You subtract something from just the x. You multiply inside the function by x. So you'll see how this works. So let's start with, it's like we're going to build a function, and we're going to start with so the first thing we're going to do, maybe I'll look at it like this, is shift left 7. So I go on here and I figure out of all these descriptions, which one is shifting left. Shifting left is right here. So what that means is inside the function, you add something to the x. For me, I'm going to add 7 to the x. So x plus 7, now since it's squared, I do this because I'm going to first add the number to x, and then, because this is so like inside the function. Now the next thing it says to do is reflect around the x-axis. So now on this, now here it doesn't say reflecting, here it says vertical flip, horizontal flip. But what it means is reflecting around the x-axis means like it turns, you make a half a turn and it pivots around the x-axis. So if you can see up here, looks like it's this one here. What they call vertical flip is where you take this and you rotate it around the x-axis, because this one is where you rotate it around the y-axis. So it's this one. So what happens is it looks like you put a negative sign way out in front. So you simply say, you put the negative sign, very first thing when you write the equation. Then the last thing says shift up 11. So I go back to my sheet and I say, which one of these is shifting up? It's like this one. And what you do, you add a number outside the function, just tack it on the very end. And for me, it's going to be 11. Up 11. So after you do all those things, this original parent function now looks like this. Now, here's one where you sort of do the opposite now. They tell you the parent function. Now they give you the final equation and they ask you what had to be done, or what's the effect of having a final equation like this. So let me do it, and then it'll maybe become clear. So here's my parent function. So here now is my final function. And what I want to do is I'm going to take the parent function and I'm going to work inside out. And I'm going to take this parent function and create this function. And every time I do something, I want to write down the impact. So in other words, we start with the parent function. Working from the inside, first thing I add 3 inside the function. Now the effect of that is when I go to my chart and I say, what's the effect of adding 3 inside the function? Here's inside the function, adding 3, it shifts it left. So the effect so now I've shifted left 3 and here's my equation. The next thing I see here as I move from the inside out is multiply by a negative, and this is considered sort of outside the function. It's outside of the square root. So what's the effect of that? It's this right here. When you multiply by a negative, it's a vertical flip. So multiply by a negative ends up being, and the effect is vertical flip. And now here's my ultimate goal. There's only one thing missing. I have to add the 2 on. So then I get my final function. What's the impact of adding 2 on to the end of the function? On my little cheat sheet, when you add 2, it's like a shift up. So from the parent function, till you build it up to your final function, you've shifted it left 3, then you do a vertical flip, or you flip it around the x-axis, then you move up 2. So just to make sure, left 3, flip, shift up 2. So 25, I guess, is another one. There's the parent function, and there's what you finally want. So let's do the same thing and see what would be required, what would happen to get that. So I'm just going to start with the parent function. So here's the goal. ½ x minus 4 cubed minus 1. Let's just do it like this. To go from here to here, working inside out, I'm going to subtract 4 from x. That's going to be inside the function. So inside the function, when you subtract 4, it's going to shift right. So the effect is shift right 4. Then I'm going to multiply in front by 1/2. So what's the effect of, that's considered like outside the function multiplying by like a fraction, like a half? A vertical squish. So it looks like there's one thing left. I subtract 1 from the very end. So outside the function, subtract 1, shift down. So the effect of this is, so you move it right by 4, you vertical squish it by half, and then you move down 1. And I think that should be what, right shift 4, vertical squish by half, shift down 1, yep. All right, so those are our transformations. Now the next couple are going to be sort of a pain. These are piecewise function story problems. I'm tempted to skip them, but see if we can figure them out. A certain state taxes the first $500 of property value at a rate of 1%. All value over 500,000 is taxed at 1.25%. Find a piecewise defined function t that specifies the total tax on a property valued at X dollars. So piecewise function means the function changes according to the value of X. So for this taxes, X is the amount of money you make, and if it's less than or equal to $500,000, then you're taxed at 1%, which is 0.01. So if you're between 0 and $500,000, your tax is going to be however much you make times 0.01. Now the tricky thing is if, this should be less than or equal to, if you're between 0 and $500,000. However, once you make more than $500,000, the tax goes up. So what I want to do is, I want to write an equation for the tax, but I need to, it's 2 parts. The tax for the first $500,000, because that's taxed at 1%. And then I add to it the tax for, I'll just put above 500,000. Because what happens is you pay 1% on the first 500,000, but anything you make above 500,000, the tax rate changes. So for this one, if you make above $500,000, then we know how much tax you paid on the first $500,000. It's going to be $500,000 times 0.01, because that's what the tax rate is. So this is the amount of tax on your first $500,000. But now, the amount of money you make above $500,000, if X is your total amount of money, then I need to subtract 500,000, right? Because if I make $700,000, then the final $200,000 has this new tax rate. And the new tax rate is 1.25%. or 0.125. So this is the equation for your total taxes if you're making above $500,000. So this 500,000 times 0.01 would be 5,000, then 0.0125x minus, let me get my calculator, 500,000 times 0.0125. $6,250. So then the final, if I combine these two, it's going to be 0.0125 minus 1,250. Hopefully, if I didn't mess up on the math. So for the 0 to 5, it's going to be 0.01x. For above 500,000, it's 0.125x minus 1,250. Yep, that's correct. Now looks like I got another one of these. An office supply company is selling bulk office supplies. They're currently running a special on black Sharpies. The first 25 will cost $1 per Sharpie. The next 50 will cost 75 cents per Sharpie. All Sharpies after 75 will cost 50 cents. Determine an equation for the total cost when a customer is buying more than 75 Sharpies. Let's see, be total cost of the next number of Sharpies ordered. So now we have 3 different levels. So basically, since we're buying more than 75, the first 25 cost $1 each. And then the next 50 cost 75 cents each. So I can figure that out. So the total cost is going to be the first 50 cost $1 each. The next 25 cost. Now everything over 75. So X is the amount we're going to buy. So everything above 75, it's going to be 50 cents. So the more you buy, the cheaper they get. So this is 50, 25 times 0.75. 18.75. Now this is 0.5x, and then minus so you combine 50 plus 18.75, subtract 3750, 3125. So 0.05x plus hopefully that's right. Oh, did I mess up? Oh, wow. The first 25 are $1. The next 50 are this. So actually, this is going to be 25. And 50 times 75, 0.75, 37.5. So basically I'm gonna have 37.5 plus 25 minus 37.5. Yeah. And that's the correct answer. All right. Let's just keep going on. Let's finish this up. 28. Now we get into quadratic equations and sort of graphing parabolas. Here's a standard quadratic, and we want to write it in the form of the parabola equation. Once we do that, give the vertex of the parabola, state whether it opens up or down, domain and range. So this is where we have to do another completing the square. So here's the equation we were given, the function x squared minus 6x plus 11. And I want it to look like that. And I need to find numbers for A and for H and for K. So the way we do it is we're going to complete the square. So I take 6 and do my special calculation, divide by 2 and square it. It's 9. So I need to add 9 here. I need to subtract 9 so I don't change the value of the equation. Now this right here factors into x minus 3 squared. 11 minus 9 is 2. So then that should be the equation. Vertex is HK. So for this H, I have to use my special rule where the minus 3 means it's going to actually be positive 3. And then the 2, K is just the 2. And opens up or down, what's the number in front of the parenthesis? It's a 1, which is positive. So it opens up. The domain and range are both all real. Is that all they ask? Yep, so x minus 3 squared plus 2, vertex 3, 2, opens up, domain. Oh, looks like I messed up on the range. Oh, because it's plus 2. So actually domain is all real. The range because this is always going to be positive and smallest it can be is 0. So it's always going to be 2. Yep. All right. Don't worry about domain and range too much on these, especially the range. So 29, going to do the same thing, different equation, all the same thing. So I'm gonna have to complete the square again. Except this one is negative 2x squared minus 12x minus 22. This one's a little tricky because when I do completing the square, I can't have a coefficient or a number in front of the x squared. So to get rid of that, I'm going to have to divide everything on both sides by -2 to get rid of this -2. So I have x squared plus 6x plus 11. Actually, let me leave some room. So now my special calculation for completing the square is 6 divided by 2, which is 3 squared, which is 9. So I'm going to add 9 here. I'm going to subtract 9 here. So then I factor this, x plus 3 squared plus 2. But now I got to multiply both sides by -2. So the vertex, here's the h. Once again, do the opposite, -3, -4. Opens down. The domain is going to be all real. The range, since it's going to open down, I think the highest point is going to be at -4. So I think it's going to go from -infinity to -4. We'll see what the key says. -3, -4 opens down domain. Yep, that's correct. All right, 30. Find the standard equation of a parabola that has vertex. So now they give us the vertex and a point, and they want us to find the equation of the parabola. All right, so this is number 30. So the vertex (0, -2). A point on the equation is 325. And they want it in this form. Of course, we know the vertex is HK. So f of x equals this, or I could call it y. H is 0, so it's just going to be x squared plus -2. So let's rewrite that ax squared minus 2. Now, if I can figure out the a, then I'm done. How do I find the a? I use this point they gave me. I plug in 25 for y, plug in 3 for x. (25) equals 9a minus 2. 9a equals 27. Looks like a equals 3. So it looks like the final equation is going to be 3x squared minus 2. And that's correct. For the story problem, if a 120 volt circuit had resistance 60 ohms, the power at watts when a current of I amps is flowing, and they give formula. So here they give us an equation. This is the power, and this is I is the current. Find the current that produces the maximum power, and find the maximum power that can be delivered in the circuit. All right. Anytime you have a quadratic equation, which is a quadratic, and you're asked about the maximum, right away you say the maximum occurs at the vertex. So basically I need to find the vertex of this equation. So we have this equation for the power as a function of the current. And the maximum is going to occur at the vertex. And since this opens down, we know it looks like this. So there's going to be a maximum. So the vertex for this kind of problem when the equation is written like this, we have a little formula, which you will not be given for the test. You need to know this. I've memorized. Negative b over 2a. So this is sort of like ai squared plus bi plus c, right? So negative, the b is 120 over 2 times a, negative 16. So it's 120 over 32. I divide that by like that would probably reduce this down to, if I divide it by 8, it's 10, it's like 15 over 4. $15 over 4 or 3.25, whichever you want. What they really want is, so this is the current. I shouldn't, I mean, really, this is really IW. So I should have called this I, the vertex. So this is the current for the maximum power. So what's the maximum power? We have to plug 15.4. I'm going to check and make sure 15.4 is correct before I do all this work. 15.4, yeah, 3.75, that's correct. Or I can write it at 3.75. So I go back up here, negative 16 times 3.75 squared plus 120 times 3.75. So the maximum power, get my calculator, 3.75 squared times 16 negative. Then 120 times 3.75. It's like 225 watts. So 225 watts is the max power, and it occurs at 3.75 amps. All right, so that was an application of knowing that the vertex is like the maximum. All right, let's finish these up. Oh, another story problem. Find the length and width of a rectangle having a perimeter of 200 meters if the area is to be a maximum. All right. So we've got a rectangle. And it says the perimeter is 200. Well, the perimeter is the distance around it. So hopefully you can see that it's 2x plus 2y. Now they want to maximize the area. Area is just going to be x times y. And let's see else what it says. So for this area, I'm going to go up here and this perimeter, I'm going to solve for y. So I have 200 equals 2x plus 2y. So I have 200 minus 2x equals 2y. Divide both sides by 200 minus x equals y. I'm going to take that. I'm going to plug it in for y into the area. So I have an equation area equals x times 100 minus x, which is 100x minus x squared. If I write it descending powers. Now I know this is a quadratic, opens down, it's going to have a maximum point, it's going to occur at the vertex. So the maximum is going to be at the vertex. So once again, if I can find the vertex, then I will know the maximum width and length. So let's find the x of the vertex. So that equation negative b over 2a. So the b is 100. 2 and a is negative 1. So it looks like the x is 50. Now if x is 50, I can figure out y. Well, here's this equation for y. Y equals 100 minus x. So that means y of the vertex is 50. So they're asking for the length and the width. Width is 50, the length is 50. And then the maximum area is x times y, x times y. All right, now we're really come down the home stretch. 3 more problems. It's like we're given 2 functions and we're asked to do a bunch of math operations. All right. So let me write down the 2 functions. We can go from there. So this is 33. So we're given f of x equals x squared plus 2. And g of x equals 2x squared minus 1. First thing they ask for, they want us to just simply add the functions together. X squared plus 2x squared is 3x squared 2 minus 1. The x squared plus 1. Then they want us to subtract x squared minus 2x squared is negative x squared 2 minus a negative 1. negative x squared plus 3. And then it was to multiply to x to the 4th minus x squared plus 4x squared minus 2. 2x to the 4th plus 3x squared minus 2. And then finally dividing, which a lot of times there's not a whole lot you can do with it once you write it out, over 2x squared minus 1. And that doesn't really simplify, so it's pretty much done. 34, now we do some composite functions. These are all f composite g, g composite f, f composite. Okay, so you write down the two functions and we can go from there. F of x equals 2x minus 5. G of x equals 3x plus 7. First thing they ask for is f composite g. And what I always do is rewrite this because it makes much more sense to me. F compose g means f of g of x, which means you take the f function, every place you have an x, you replace it with the whole g function. So the f function is 2 times x. Instead of x, I put in the whole g function, minus 5. This is going to be 6x, 2 times 7 is 14. 14 minus 5 is, should be 6x plus 9, hopefully. Then the next one is g composite f of x. So that's the same as saying g of f of x. You take the g function, 3x plus 7, replace f of x, you replace it with the f function. So 3, 2x minus 5 plus 7, which is going to equal 6x. So this is a minus 15 plus 7. 6x minus 8. Now what's interesting is they go back to f composite g, except instead of x, they actually plug in a value. But you know what? Since I've already calculated f composite g of -2, I can just plug it in. So it's 6x plus 9. -12. Looks like -3. Although let me show you. If you, they don't do that, but just if you were not given these first two parts, say they just gave you this, and they asked for this, there's a simple way to do that. Let me just do one for fun. Or actually, what's the next one? I could use this, but instead, let's pretend I didn't have this and I was just starting. This is the first part of the problem because I want you to see this, because you could do it either way, but this is actually much simpler for starting from scratch. Let me write this g right? G composed f of 3 is the same as G of f of 3. Now, I'm going to go off and I'm going to figure out what f of 3 is. F of 3 says you take your f function and you just plug in 3. 6 minus 5 is 1. F of 3 is 1. Since f of 3 is 1, I can now go back up here and say G of f of 3 is G of 1. And I simply now go to my G equation, plug in 1, and I get 3 plus 7. And there's my answer. So when you're asked a composite and you replace an x with a number, you can do this very simple. Makes it very simple. All right, the last problem, 35. Another composite problem. Two functions. See, f of g of x is another way of saying f composite g. So it's really another composite. They call it a composite function. So f of x equals 5x squared minus 2. G of x equals 3x plus 4. And they want to know f of g of x. Take the f function, replace it with the g function. So 5x squared becomes 5, 3x plus 4 squared minus 2. Got to FOIL this, 5. It's got to be 9x squared plus 24x plus 16. Now multiply out the parentheses, it looks like 45x squared plus 120x. 5 times 50, it's 80 minus 2. See if my math is correct. And it is. All right, so that was the test number 2 review.